So in the last class, we have completed discussion about the LTI systems, right? And I told you it's a very, very important chapter as far as GATE examination is concerned, right? So we started discussing about the impulse response, and then we have seen the process of convolution. First of all, by learning how to represent a signal in terms of impulses, right? And then we have started discussing about the discrete time convolution, the important observations in the discrete time convolution, and how we have used the tabular method to solve the problems of the discrete time convolution, right? Later, we have seen the convolution of a signal with an impulse. And after that, we have seen a convolution of a signal with a step, right? So convolution with an impulse, convolution with a step. These are very, very important topics. Then we have learned about the different properties, right? Time shifting property, time scaling property, time reversal property, right? So all these properties we have learned, especially the cascading property, very, very important property as far as examination is concerned. Parallel connection. So all these things we have seen, and we have also extended the concept of digital convolution to the continuous time convolution. And here also we have written the important observations, right, about the lower limit, upper limit, width. So what is going to happen when you're convolving two rectangular pulses of same duration, unequal duration, right? So finally we have discussed about the step response, and also we have discussed about how to tell a particular system is going to be causal, stable from the concept of the impulse response. So this is complete LTI systems, and because LTI systems is completed, now this is your duty to start writing the short notes for the LTI systems and complete it, and try to ensure that before completing the signals and systems, as much times as possible you try to revise a particular short notes whatever you have written. And I have already told you in the last class how to write the short notes. You have to first of all visualize all the important concepts that you have learned and from where the questions are going to come, and you have to ensure that you are writing all those things which are important in the examination point of view. Leave some gaps, and the gaps can be filled with something that is coming to your mind and you think later that it is an important thing, right? So that is how you have to write your short notes. It's a very, very important step. Now, till now, in signals and systems, we have seen everything in time domain, isn't it? Whether we have started discussing about the first chapter, which is Introduction to Signals and Systems, or the second chapter, LTI systems, we did not bring the concept of frequency into the picture, right? So whatever data which is required for us, whether to calculate a signal, whether it's energy and power, whether to find whether the signal is going to be even signal or odd signal, periodic or not. Okay, so all these things that we have done, we try to analyze as much as possible, but in the time domain. Whether it is a signal or it is a system, the approach is that till now, whatever is possible, entire thing we have done only in the time domain. Now this is the time that we go into the frequency domain of a signal, because frequency domain is also going to give you a lot of information about a particular signal. For example, whether a particular signal which is given, whether it has a higher frequencies or lower frequencies, and how you are going to process the signal also depend upon the accurate system. Whether the system that you are selecting is suitable for that particular signal or not, suitable for that particular signal which is having some frequencies or not, right? So these are the things that we will come to understand that only when we know the frequencies which are present in a signal. Because once you know the frequencies which are present in the signal, then only you will be positioned to understand how to process that particular signal in the later stage. Number one. Number two, the same thing with the system also, that you have to know how a particular system is going to function with respect to different frequencies, right? How a particular system is going to function with respect to different frequencies. So for example, if you are having a bipolar junction transistor, which generally we use as an amplifier, right? If it is able to amplify the signals which is having lower frequencies, but it is not able to cope with the frequencies which are higher, then there is a problem with the system, right? Then whatever is we are looking for, because we want such a system which can amplify the signal of all frequencies, but you now encounter a problem that a signal can be amplified only at lower frequencies, but it cannot be amplified at higher frequencies. This is something you will learn only when you know the frequency response of a particular system, right? So unless and until you do not understand what is the frequency response of a particular system, you will be incapable to understand how your system is going to function with respect to frequencies. And in the same way, as I already told you in the previous class when we discussed about the impulse response, that we will be applying some tools so that we calculate the transfer function, we calculate the frequency response of a particular system, which of course is a very, very important topic for us, right? So now the thing is that in today's class we are going to enter into a particular domain which we haven't dealt till now. Okay, we haven't seen anything related to frequencies till now. So there is a chance that you will face difficulty in understanding the concepts, right? Because you are going to something which you haven't seen before till this particular class, right? So definitely you might be facing some problems, but ensure that you are writing your proper notes, keep your patience, ensure that okay, you are attentive in the class, so that whatever is going on class, at least you are not losing track of it, right? Is it clear to all of you till here? Right, so the Fourier analysis, we are going to discuss the Fourier analysis. We are going to discuss initially in this chapter. We will be focusing on the continuous time signals only. Right. So we are going to start with the top of the Fourier analysis. We will be focusing on the continuous time signals only. We will be focusing on continuous time signals only, and later we will be seeing it for discrete time. So this chapter completely we will be dealing with continuous time signals only. Right, so continuous time Fourier analysis, it is majorly divided into two parts. One is Fourier series. One is Fourier series and the other is Fourier transform. One is Fourier series and the other is Fourier transform. So Fourier series is helpful for the same purpose. See, both of them are having same purpose. The purpose is that to know the frequencies in the signal. To know the frequencies present in the signal. So the purpose of this particular tool, the Fourier analysis, is to do a very simple job. To know the frequencies which are present in a particular signal. To know the frequencies which are present in a particular signal. But depending on the signal, we will be having two approaches. One is Fourier series, the other is Fourier transform. Okay, so these are two transformational tools under the same name of Fourier analysis. Okay, later we will come to know that both of them are very similar, right? It is only the manipulation or extension of Fourier series you will be having Fourier transform. Okay, but as such, if you see the formulas, you will feel that they are two different tools. But actually, if you understand mathematics, you will see that it is just the extension of Fourier series. You will be having a Fourier transform. So we will be starting with Fourier series, and then we will go into the Fourier transform. Okay, so what you will be learning in Fourier series? Of course, same thing. The purpose is the same thing: to know the frequencies which are present in the signal, to represent the frequencies which are present in the signal. But here we will be dealing with the signals whose nature is periodic in nature. Okay, so we will be using Fourier series only on periodic signals. We will be using Fourier series only on periodic signals. Whereas Fourier transform, we can use essentially for non-periodic. Essentially for non-periodic, because periodic is taken care by Fourier series. Something which is left for us is nothing but non-periodic signals. But your Fourier transform is more a generalized tool when compared to the Fourier series. So even if you are having a periodic signals, that can be dealt by the Fourier transform. But because the periodic is taken care in the case of Fourier series, will not put a lot of focus on the periodic signals as far as the Fourier transform is concerned. Our major focus will be on the non-periodic signals. Our major focus will be on the non-periodic signals. That is why when we see the functions on which we are applying Fourier transform, you will be seeing majority of them are going to be non-periodic in nature, because periodic is something which is taken care in the case of the Fourier series. Right, so this is the major difference between the two of the Fourier series and Fourier transform. One will help you for periodic, the other essentially for non-periodic, but it can also take care of the periodic signals. So these are the two tools that we are going to learn. And once we complete the chapter of Fourier series and Fourier transform, let me tell you, you will be considering this topic as the much tougher when compared to the whatever we have seen till now. Okay, we have seen about LTA systems, we have seen about introduction to signal systems. When compared to that, this looks slightly more tougher, but this is the important part in such a way that once you know Fourier series and Fourier transform, Laplace, Z and the remaining things are going to be very simple for you. So this part is going to become a very important in understanding. Okay, you will face a challenge in understanding, but once you are attentive in the class, you are regular to all the classes, and you keep asking the doubts that you are having, the problems you are having, then you will be in a position that you will understand how the gate questions are going to come. Okay, how we have to focus on this particular chapter, what are the areas from where consistently the questions are going to come. Once you understand that, then you will be very comfortable with this particular chapter. Okay, so initially it requires a lot of patience. Initially it requires a lot of patience because you are entering into a territory which is unknown for you as of now. Okay, slowly you will get that confidence that yes, I can deal with this particular thing. Till then, you have to keep patience, you have to be attentive in the class, you have to write your notes properly and ensure that whatever doubts you are coming, you please ask in the doubt solving part so that things remain clear for you. Now once Fourier series and Fourier transform is dealt, then nothing is present in signals which is going to bother you. Okay, whether it is Laplace transform, whether it is Z transform or the remaining techniques that we are going to learn, nothing is going to bother you. This is the only chapter which is slightly more challenging as far as understanding is concerned. This is also a chapter where we use a lot of formulas, where a lot of mathematics, but majority of the formulas that we are going to use are not very much mandatory to remember. Okay, there are very less such formulas which are essential to solve the problems. Majority of the problems can be solved directly using the properties or the important things that we are going to discuss. Remaining all formulas, maybe they are complicated, but nothing to bother about it. Okay, once you come to the gate problems, you will understand that how the questions are going to come, then you will be little bit more relaxed. Okay, initially you will be having a lot of equations which you have to go through so that we get a bigger picture of the concept of Fourier series. Okay, so as of now, initially we will be focusing on Fourier series for the next two classes, and then we will go into the concept of Fourier transform. So is it like mathematics in the probability? That all depends upon the person, right? Mathematics is not difficult for all the students, right? Probably for some students, mathematics is like, mathematics probability is like a hell, right? But if you practice more number of problems, you will understand, okay, the probability, how to deal with the probability. It is not like that. Please don't leave probability. Probability is a very important topic, both in mathematics as well as aptitude. In both the cases, you are going to get questions from probability. Okay, so if you are facing any problem in probability, please try to practice the problems and ensure that you are reaching a level of comfort. Right? It is not a good thing to leave probability. Later on, even when you go for your masters, you will be using probability a lot. So in every way, probability is very important. Right? So whatever problems that we see, that the limitations that we learn from Fourier series and Fourier transform, that we will solve using the another tool called as Laplace transform. Laplace and Z both are one and the same, right? So whatever problems that we encounter in the case of Fourier series and Fourier transform, that will be solved using Laplace transform, right? So one more chapter you have is a discrete Fourier transform, discrete Fourier techniques, which, because here we are seeing for continuous, we will also be seeing for discrete. But if you see the importance, okay, of course, the discrete importance is increasing day by day. Okay, if you see the pattern, 2018, 2019, the weightage of discrete is increasing. Okay, the weightage of discrete is increasing. Now slowly and slowly, even discrete is also becoming important. But as of now, the major focus will be on continuous time. Once you have understood continuous time, you will be more comfortable with the discrete time.